Today our topic is molecular orbital theory. We know, according to valence bond theory for chemical bonding, oxygen is diamagnetic in nature, but in actual oxygen is not diamagnetic in nature, oxygen is paramagnetic in nature. Valence bond theory is unable to explain magnetic nature of the molecule spherically, so was discarded, and instead of VBT, MOT, that is molecular orbital theory, was used. This molecular orbital theory was given by Hund and Mulliken. According to Hund and Mulliken, atomic orbitals of different atomic atoms combine together to form molecular orbitals. And these atomic orbitals will be of approximately same energy level. Then only will combine with each other to form molecular orbitals. Atomic orbitals of different atoms combine together to form molecular orbitals. These atomic orbitals must be of approximately same energy level or comparable energy level, then only will combine with each other to form molecular orbitals. Total number of atomic orbitals must be equal to the total number of molecular orbitals. Suppose if one atomic orbital combined with another atomic orbital, then the total number of molecular orbitals formed will always be 2. Half of the molecular orbital will be having energy. Half of the molecular orbital will be having energy lesser than atomic orbitals and will be known as bonding molecular orbitals. Remaining half molecular orbitals will be having energy greater than the atomic orbitals and will be known as antibonding molecular orbitals. Half of the molecular orbitals formed will be having energy lesser than the atomic orbitals, and remaining half molecular orbitals will be having energy greater than the atomic orbitals. Molecular orbitals having energy lesser than atomic orbitals will be known as bonding molecular orbitals, and molecular orbitals having energy greater than atomic orbitals will be known as anti-bonding molecular orbitals. Bonding molecular orbitals are always attractive in nature, are additive in nature, are constructive in nature. Because of them, bonding will be possible between two atoms, and anti-bonding molecular orbitals are repulsive in nature, are subtractive in nature, destructive in nature, will always oppose bonding between atoms. This number of bonding molecular orbital and anti-bonding molecular orbital will be playing very crucial role there in bond order between two atoms, that is number of bonds between two atoms also. So, as atomic orbitals follow Pauli's exclusion principle, Hund's rule, ABMO principle, molecular orbitals also do the same. Molecular orbitals also follow ABMO principle, Pauli's exclusion principle, and Hund's rule. As atomic orbitals have their own quantum numbers. As atomic orbitals have their own quantum numbers, molecular orbitals also do the same. Molecular orbitals also have their specific quantum numbers. So these are the main postulates of molecular orbital theory. These are the main postulates of molecular orbital theory, which was given by Hund and Mulliken. According to this molecular orbital theory, atomic orbitals of approximately same energy level combine together to form molecular orbitals. These molecular orbitals will be equal in number to the sum of the number of atomic orbitals. Half of the molecular orbitals will be having energy lesser than the molecular orbitals. Remaining half molecular orbitals will be having energy greater than the antibonding molecular orbitals. Bonding molecular orbital favors bonding, while antibonding molecular orbitals opposes bonding. Bonding molecular orbitals are attractive in nature, additive in nature, constructive in nature, means they will favor chemical bonding, while antibonding molecular orbitals are repulsive in nature, subtractive in nature, destructive in nature, means will oppose chemical bonding. As atomic orbitals follow Pauli's exclusion principle, Hund's rule, and Aufbau principle, molecular orbitals also do the same. Molecular orbitals also follow Pauli's exclusion principle, Hund's rule, and Aufbau principle. As atomic orbitals have their specific n, l, m, s values, that is quantum numbers, molecular orbitals also do the same. Molecular orbitals also have their own specific quantum numbers. This was about molecular orbital theory. Now its application, what type of questions on the basis of this molecular orbital theory they can ask us, we'll discuss that. As suppose they have given molecular orbital diagram for H2 plus or H2 minus. H2 minus means H plus plus H minus. Electronic configuration of H will be 1s1 and electronic configuration of H minus will be 1s2.